Alright, you are currently watching video E5.p1-17, which is notes motion of our solar system in our galaxy. The learning target for this is going to be E5.p1d, which is describe the position and motion of our solar system in our galaxy. If you've already watched the video for E5.p1-16, that was the one that dealt with our position, where we're located with regards to the Milky Way galaxy and how close we are to the central bulge. Now what we're going to do is we're going to talk about how quickly we are actually moving, not only here on Earth, but in our solar system and then also in our galaxy. So we're going to talk about speed. We're going to be using some numbers. We're going to be using some math. So my suggestion before we get started, if you have a calculator, I would suggest that you have it out because you're going to be asked to do some calculations. And if you don't feel comfortable, that's perfectly fine. You can follow along and do the math as I do it on the screen for you and with you. Okay? So let's go ahead and get started. So as I've already mentioned, the learning target is E5.p1d, which is the description and describing of the position and motion of our solar system and our galaxy. And for this one, we're only going to be describing the motion as we've already gone over position. Alright, so cool little picture as you've already seen, again, of a bunch of different pictures that were taken and all fused together to make this one gigantic picture poster of our Milky Way galaxy. And these are all pictures that are actually taken from telescopes on Earth to put them all together to see what our Milky Way galaxy looks like as we are looking at it from roughly around 260,000 light years away from it. So from the center of the Milky Way galaxy. A little struggle there. All right, so here we go. Again, as we talked about with our position, where the sun is located, we are located in the arm of Orion, or sometimes called the Orion spur, depending on who you talk with. But Orion arm or the Orion spur is where we are currently located within the Milky Way galaxy. So let's talk about motion, and these are going to be numbers that are going to be quite large and quite hard to understand. So I'll try to break it down for you as best I can, and then if you should have any further questions, do not hesitate to ask myself or Mr. Fuzak for some more detail or clarification. So let's talk about the number in which is going to just kind of hit you and be like, "Are you kidding me?" To start off. All right. So each day that you wake up in our 24-hour period, so each day we travel almost 1.6 million miles around the sun. So as we start to make our revolution and start to travel around the sun, in one day's time, we travel 1.6 million miles. So how fast is that? That works out to 18.5 miles per second. Now, for those of you who are people that go out to watch cross country or maybe even go out to watch track, think about a mile. A mile on the track is relatively 4 laps. So if light, how fast Earth is traveling, this huge massive Earth that we live on is traveling 18.5 miles a second. You're doing the math on that and you're going, how many times? That's a lot. That's almost 70 plus laps around the track in 1 second. In 1 second. That's how fast we're traveling. It's crazy. Which means if you want to see it in minutes, we're going to travel roughly at about 100 and give or take 1,110 miles per minute. And if you want to do it in an hour in which you are currently sitting in class, you're going to travel, we've traveled in 1 hour that you've been in class, 66,600 miles in 1 hour. Again, the numbers are huge. It's hard to understand and hard to comprehend exactly what's physically taking place, but those are the numbers. They're ginormous. They're huge. So each day we're on Earth, we travel. Okay, we travel 24,855 miles on our axis. Our axis is where we are currently spinning around. Spinning around and around and around. And we make a travel distance of 24,855 miles on our axis. That means on our axis, we are traveling 0.3 miles per second. So again, you're doing the math on that. If you go out and do a quarter mile, that's 1 lap. That's how fast we're rotating on our axis, how Earth is spinning, just on its axis. Not spinning around the sun, because we've already said we're traveling around the sun at 18.5 miles per second, but just spinning on our axis, just our very own 0.3 miles a second. And then you can see how fast that is when we work up to it in 1 hour. So literally sitting in your chair, you have made 1,440 miles. That's been your movement while sitting in your chair. Earth has started to spin on its axis that much. And again, it's got a long ways to go over the course of a full day, 24 hours. So the sun is about, as we mentioned with our position, about 26,000 light years to the center. So we're looking at the center bulge right there, right smack dab in the middle. Which means that the Milky Way galaxy from one end here all the way across to the other end over there is 100,000 light years across. And then if we want to make it simpler, how quickly things move, from the sun to Earth, it takes I think it's like 8.2 or 8.3 minutes for light to travel. So if the sun were to go out 8.2, 8.3 minutes later, you and I would see no sun in our sky. And the temperatures would start to drop because we'd have no radiation coming to heat up our atmosphere. Kind of crazy. But how far is this? Well, when we look at distance, and we're talking about how fast we're going, again, we go back to that number, 5.8 quintillion. Quintillion miles is how far that distance truly is from one side of our galaxy to the other. The Milky Way galaxy is large, but it's definitely not the largest. Andromeda galaxy, if you want to Google that, Andromeda galaxy is the largest in what's called our local group, which is 4 major galaxies, all pretty close to one another in regards to space. But yet we're still hundreds of thousands of light years away from one another. Again, crazy. So if that's how far we are, let's talk about motion again. It takes the sun in our solar system roughly 200 to 250 million years to orbit once around. So we're talking take one trip around the track to come back to the place in which you currently see it here. It takes 200 to 250 million years to go around once, the central bulge, one time. So that's crazy when you're looking at it as to how far this goes in 1 year, talking about distances, 200 to 250 million years just to go around one time. So in other words, the last time the sun was in our current position was when we had those things called dinosaurs. Dinosaurs, when they were roaming the earth, that was the last time that the sun in our current location had made one complete revolution around the central bulge, or one orbit. So the sun has only done this 20.4 times when it formed 4.6 billion years ago. Okay, so we're talking about distances, we're talking about speed, we're talking about time all together. So our sun formed 4.6 billion years ago, which was a globular cluster of nebula, which we'll talk about what those things are. And those dusts and gases, because of centrifugal force spinning around and around and around, cause these things to squeeze and then kind of group together, and our sun was formed. And that has only allowed, based upon the time, the sun to travel around our galaxy. The Milky Way galaxy has only gone around the central bulge 20.4 times over the course of the history of this galaxy. So if we take the current estimates by people that are studying this stuff, we're looking at about 7 billion years before the sun's energy will burn itself out and we'll no longer have a sun, at least in the form in which we currently know our sun to exist. Which means we have 31 opportunities, 31 more times for the sun to go around the central bulge of the Milky Way galaxy. It has 31 more opportunities. So in this orbit, okay, when we're talking about our solar system, we're talking about our sun, how fast is this going? Well, in order for this to happen, based upon our revolution and our orbit around the central bulge in the Milky Way, that means that we're traveling at about 155 miles per second, which means, and I Google mapped it just to see where a location in Michigan from one place to another at 55 miles was, and it's I think 154 point something miles to South Lyon, which is all the way over near Detroit. So in 1 second, 1001, that's how far we have physically moved in our orbit around the Milky Way galaxy in 1 second. So we've gone from here all the way across to South Lyon. So again, in 1 second, that's how far our solar system, how our sun and all of our planets within our solar system, including Earth, are traveling around the Milky Way galaxy. So since the sun is 26,000 light years away, okay, we've already done the math on this, and it's a long ways from the center of the Milky Way, it has to travel at this speed as it goes around the Milky Way. So that means that 485,912 miles an hour is how fast we are traveling around the Milky Way galaxy per hour. 485,912 miles per hour. And what that means is you could travel around Earth. So you take our Earth, you go on the outside of it, and you run around Earth. But you're running around at the speed of light. You could travel 19.5 times around Earth in an hour. That's crazy. Again, just absolutely crazy with regards to how far speed goes. So just for comparison, the Earth is rotating at a speed of 1,100 miles an hour, which means that if we're moving on our axis, we're spinning, Earth is spinning, Earth is spinning, Earth is spinning, at 1,100 miles an hour, we are spinning and revolving around the sun. Here's the sun, and we're revolving around it at a speed of 67,108 miles an hour. So every hour we're traveling 67,108 miles an hour to go around it. So over the course of a 24-hour period, we have traveled millions of miles around the sun, and yet that was only 1 day, and it takes us 365 days to go around the sun one time. So again, when you're dealing with the position and the motion, you're dealing with numbers which are quite astonishing. They're large, they're huge, and it's quite difficult to understand. But I want to give you a perspective that we're traveling at speeds faster than you and I can understand, because our bodies have become so accustomed to what we're physically feeling, what we're physically a part of. And that's why we don't feel like when you jump on a roller coaster that as you feel the gravitational force forcing against you, because we already feel that on a constant basis. We're not feeling something new. Now, if things were to change and Earth were to speed up or slow down, would we feel it? Yes, we would notice it, because our bodies have become so used to what we currently feel. So just a completely different perspective, something that you may have never even heard before with regards to how fast Earth is traveling around the sun, how fast Earth is traveling on its own axis, how fast the sun and all the other planets within our solar system are traveling around the Milky Way galaxy. Pretty amazing stuff.